the Physical Science Section 6.4 lesson video, and as always, if you like all my videos for the whole year of physical science, just subscribe to my channel. So we're going to talk about the structure of metals. So if you've watched the previous videos, we've talked about ionic bonding, we've talked about covalent bonding, so now we're going to talk about metallic bonding. So in a metal, valence electrons are free to move among the atoms, so the cations are surrounded by a sea of electrons. So in normal compounds, once an electron belongs to a specific nucleus, it stays with that nucleus. So if it's transferred from one to another, it stays with that other one. If it's going to stay with the one it's originally with, it stays there. If it's being shared between two, it stays there. But in metals, those valence electrons are free to move around. So like even if it starts with this nuclei, then it can move over to this one, and then this one, and then this nucleus, so forth and so on. So it doesn't belong to any one specific one. So a metallic bond is the attraction between a metal cation and the shared electrons that surround it. So you have these positive metal ions in the middle, and then you have the sea of electrons. It's called sea of electrons because they kind of flow around wherever they want. And that's very important that they can flow, because we'll talk about why that makes them good conductors. The cations in a metal form a lattice that is held in place by strong metallic bonds between the cations and the surrounding valence electrons. So a metallic bond is the bond between the positive metal ions and the sea of electrons, because the electrons are of course negative and we know opposites attract. The more valence electrons an atom can contribute to the shared pool, the stronger the metallic bond will be. So here we just have a few electrons in our sea of electrons. Here we have a lot of electrons in our sea of electrons. So this would have stronger metallic bonds than this right here, because there's more electrons in the sea of electrons. The mobility, which means that they can move, the mobility of electrons within a metal lattice explains the fact that metals are good conductors and malleable. So the fact that the electrons can move around, that's what makes metals good conductors, because remember, think about conducting electricity. We need charges that can move. Well, the electrons can move and they have charges. So they're good conductors. They're also malleable. The thing is, if you try to hit a metal, see how we did start all lined up and then we hit it, then what happens is, because think of, the sea of electrons as being actual liquid. It's not, but just think of it. Then those metal cations can just kind of shift over a little bit. And so that's what makes them malleable instead of shattering like a non-metal or something like that. So that sea of electrons is what contributes to metals being good conductors and being malleable. So, can we mix metals together? Well, an alloy is a mixture of two or more elements that have metallic properties. So you can have nonmetals in an alloy, but at least one of them needs to be a metal. So for example, sterling silver is a mixture of copper and silver. Those are both metals, and overall they act like a metal. Brass is a mixture of copper and zinc, which are both metals. But for example, steel has carbon in it, which is a non-metal, but its main component is iron, and steel overall has metallic properties, so it is also an alloy. So in an alloy, it is possible to have non-metals, but overall the alloy must have metallic properties. So, section assessment. What holds metal ions together in a metal lattice? Well, remember, the metal cations are attracted to the sea of electrons. The metal cations are attracted to the sea of electrons. So number 2, what characteristic of a metallic bond explains some of the properties of metals? Well, remember, we said we could explain why metals are good conductors and malleable because of the sea of electrons, or the fact that the electrons are mobile. Okay, so the characteristic is it has those mobile electrons. So number 3, explain why the metallic bonds in some metals are stronger than bonds in other metals. Well, remember, the strength of the metallic bond is based on the number of valence electrons. So the more valence electrons in the sea of electrons, the stronger the bond. So the more valence electrons in the sea of electrons, the stronger the metallic bond will be. So number 4, why are metals good conductors of electric current? Because the electrons can move. Remember, we need charges that can move to conduct electricity. If you haven't noticed, we've discussed this in many different chapters. Okay, they're all connected. All right, and then number 5, can two different elements form a metallic bond together? Yes, they can, and then they form an alloy. All right, they form an alloy. So hopefully now you understand a little bit more about how metals bond and alloys.